Hi, I'm Jason and welcome to this section of the Pre-Algebra Tutor. And in this section we're going to tackle the very important topic of adding fractions together. Now we've kind of danced around this subject a few times already because I kept telling you that some of the things that we were doing in the previous sections were going to be directly applicable to adding fractions, subtracting fractions, and on and on and on, and now we finally get to this point. Basically, in a nutshell, what you need to know, the most important thing to take away from this section is that in order to add fractions together or subtract them from one another like we'll do in the subsequent section, the denominators of those two fractions, or however many fractions you have, must be the same. They have to be the same. So if you try to add 1/4 plus 5/8, you cannot do that unless those denominators are the same. And if they are not the same, then it's up to you as the person working the problem to make them the same. And that's why we covered finding the common denominator so much, because basically every time you try to add or subtract fractions, the first thing you're going to do is check to see if those denominators are the same. If they're already the same, then you can just keep on going with adding the fractions. But if they're not the same, most of the time they won't, then you'll have to find a common denominator. And now that we've already done an entire section on finding a common denominator, shouldn't be that big of a deal to go on and do it. So let's just dive right into the problems. I think what you'll find is it's really not that difficult to add fractions, but the basic process is check for that common denominator. If they're not the same, force them to be the same through our methods. Then you add the fractions, then you try to simplify the result. And we've done all of these little steps in different parts, and now we're going to put them all together and learn how to add fractions. So for our first problem, let's pick an easy one. Let's say 1/5 plus 2/5. Now remember, what is a fraction? I mean, you should really kind of have a mental image. You have a pizza, you cut it into 5 pieces. This guy has one of those 5 pieces. Another person cuts another pizza up, takes out of 5 pieces, he has only 2 of them, so this guy has 1 out of 5 pieces, this guy has 2 out of 5 pieces. We add them all up. How many pieces do you think we should have? Well, if this guy has 1 out of 5 pieces, and this guy has 2 out of 5 pieces, then the answer is 3 out of 5 pieces. That's what we do when we add these two fractions together. And it makes sense when you say it out loud because the denominator is the same in both cases. So when you say it in the form of a sentence, it kind of makes sense. If this guy has 1/4 of a peanut butter and jelly sandwich, and this guy has 2/4 of a peanut butter and jelly sandwich, and you add them together, then you have 3/4 of a peanut butter and jelly sandwich. It only makes sense, though, if that denominator is the same. If they're not the same, you can't really do it right away. So first step, check to see if this is equal. It is. So when you're adding fractions, the denominator of the new fraction you get is always going to be the same as what you started with. 5, so this one's going to be 5. In the numerator, all you do is add together the numerators. 1 plus 2 is 3. And then finally, we check to see if this is simplified. And this is already simplified. I can't really divide top and bottom by anything to make this fraction simpler. Now, what if we had 4/5 plus 3/5. So again, we check to see, are the denominators the same? And they are. So the denominator of our new fraction will be 5. It'll stay the same. You don't add them or anything. You just keep the new denominator. And then you add this together. 4 plus 3 is 7. So the answer is 7/5. And you can, you can leave it like that, but you realize this is an improper fraction, so you should try to change it to a mixed fraction. How many times will 5 go into 7? We'll go 1 time. And so that's 1 times 5 is 5. The difference between 7 and 5 is 2, so your remainder is 2, and you always write it out of 5. We've done that before in previous sections, so 1 2/5. So here's the answer to this problem. Here is the answer to this problem. And just so we don't go cross-eyed here, I'll try to use some different colors to break up the board a little bit. What if you have -4 over 5 plus 2/5? Now don't be worried if this is a negative fraction. It really is going to make a lot of sense what we're going to do here. First thing you do is check, are the denominators the same? And they are, so the denominator of our answer will be the same. Now in the numerator, we simply add these things together, but don't try to do too many things in your head. Just, if you need to, write it down, -4 plus 2. This is what's going to be in the numerator, and that way you don't make a mistake. So in the numerator, -4 plus 2 is -2 over 5, -2/5. And that's the answer. And one thing I'm going to show you with fractions, if you ever get a negative sign in the top, or if you get a negative sign in the bottom, that negative sign, when you have a negative in a fraction, it can sort of float around anywhere you want. So you can leave it like this, it's perfectly fine. But that's exactly the same thing as sticking it out in front, -2/5. So this negative sign can stay up top, you can move it to the bottom, you can move it out in front. It can float around anywhere you want as long as you have a negative somewhere. It just tells you that the entire fraction is negative there. And the reason it's negative, by the way, is because this guy, he didn't have any pizza at all. He actually had -4/5 of a pizza. So he actually owed somebody else 4/5 of a pizza. So when you add to that 2/5, the net result is he still owes somebody 2 out of 5 pieces. And that's why it's like that. So let's continue on. 5/7 plus 6/7. So we check, the first thing we need to do is check and see if these denominators are the same. And in this case they are. The denominator is 7, so we keep the same denominator. Next we add the numerators. 5 plus 6 is 11. And that is the answer, 11/7. Now we can keep it like that, but really we should try to convert it to a mixed fraction if we can. How many times can 7 go into 11? It can only go one time because 7 times 2 would be 14. That's too many. The remainder we have is 11 minus 7, and that's going to be 4, so that remainder is always written over the base fraction, so 1 4/7. What if we had 3/10 plus 2/10? First thing we do, check the denominators. The denominator is the same in both cases, so we keep that denominator. Then we just simply add 3 plus 2, we get 5. We always again check to see, is our answer fully simplified? Well, in this case, we have 5/10, so we can divide the top by 5, we can divide the bottom by 5, and the final answer we would get is 1/2. 10 divided by 5 gives you the 2 there, so we have the 1/2. So the process is the same, and I'm giving you sort of some nice problems to ease you into it, giving you the same denominator to begin with. What if we have 13/7 plus 1/7? Plus 1/7. Well, we check the common denominator. In this case, it's still the same. The numerators, 13 plus 1, we just add to give us 14. So we look at this, and we ask ourselves, is this already simplified? Well, we try to divide. How many times can 7 go into 14? It can go 2 full times, and there's no remainder at all, so the answer is just 2. So that's the answer. Now, what if we had 11/12 plus 7/12? We check to see, are the denominators the same? They are, so we keep them. The numerators, 11 plus 7 gives us 18. And again, that's the answer, but it's improper, so let's try to convert it. How many times will 12 go into 18? It'll only go one time. The remainder is going to be 18 minus 12, which is 6, and you write it over 12 like this. 6/12 is going to reduce to 1 1/2. And the way you get from here to here, you divide the top by 6 and the bottom by 6. 6 divided by 6 is 1, 12 divided by 6 is 2. So this is the final answer, 1 1/2. What if we had -7/15 plus 2/15? We check to see if these denominators are the same, and they are. So let's write it like this. Now in the top, we have a negative sign out in front of this fraction. Remember what I told you. This negative can float. You can put it in the top, you can put it in the bottom, you can put it out in front. So we're going to stick it to the top because we're going to add it with the plus 2. So the final guy is -7 plus 2 is -5. And that fraction is not simplified because I can divide the top by 5 and the bottom by 5. The final fraction I get, I'll take this negative sign out in front. 5 divided by 5 is 1. 15 divided by 5 is 3. So -1/3. -1/3. All right? And we're slowly just kind of introducing new things here and there. We're putting negative signs in. We're getting into improper fractions. Let's go ahead and do one here that's a little bit different. -7/16 plus -3/16. So we're just doing one a little different here where we have two negative fractions, but it's going to be exactly the same process. The denominators are the same, so we're going to keep them the same. Okay? In the numerators, we have -7, and then over here we have -3. So the way I'm going to handle that is I'm going to put plus -3, just to make it absolutely clear what I'm doing, plus the -3. So over here, what's -7 plus -3? And as you should remember back to adding our integers, that's going to be -10. right? That's going to be negative 10. Now this fraction is not fully simplified because I can take and divide this by 2, and I can divide the bottom by 2. So the final answer, don't forget the negative signs there, is negative. 10 divided by 2 is 5. 16 divided by 2 is 8. Negative 5/8 is going to be the answer there. All right, let's do a couple more of this base type, and we'll get into some mixed fractions. What about 7/5 plus negative 12/5? Okay, denominator's the same, so we'll just keep it there. And in the top, we'll have 7 plus this negative 12, like this. And then the denominator will stay there. What is 7 plus a negative 12? You should be able to convince yourself there that that should be negative 5. Negative 5. And so what's 5 divided by 5? That's 1, but of course you have a negative here, so it's negative 1. So that's the final answer, negative 1. Now you may have noticed that I'm giving you a ton of problems in fractions. We're not even done yet. We're still getting started with really giving you practice with adding fractions. The reason I'm giving you so many is because honestly, if there's one thing that I think is really, really important to understand and to master in all of pre-algebra, it's gonna be fractions. Because what most people do when they get upset and worried about an algebra equation or something else going on later down the road, it's usually because they're uneasy with fractions. They don't know how to handle it. They don't know how to simplify them. They don't know how to add them. The idea of a common denominator, just they never really quite understood it, and so it bugs them. And that can really turn your brain off. But I promise you, if you get good at fractions, adding, subtracting, dividing, multiplying them, then later when I give you a big equation with a giant fraction bar, in the middle there, with a big numerator and a big denominator, it's not going to bother you because you're going to have such a great understanding of fractions. So work these problems. Make sure you're following every one of them and work them yourself because it's really, really going to help you tremendously. Let's get into some mixed fractions. What if I gave you a 3 1/3 plus 2 2/3? Now, when you have mixed fractions added together here, don't forget what they are. This is 3 full pizzas plus another third of a pizza. This is adding together to it 2 more full pizzas plus 2/3 of another pizza. That's what this is telling us. There's actually a couple different ways you can go about doing this. My favorite way, if I have positive fractions here and I'm just adding them together, it makes sense to me to just do it as the following. What is this 3 pizzas plus these 2 pizzas? That's going to give us 5 whole pizzas. But now I need to add these fractions together. So what I'm going to do, the denominators are already the same, so I'll leave them the same. The numerators, 1 plus 2 is going to give us 3. So what do you see here? 3 divided by 3. So you're going to have 5 plus 1 whole pizza given by this, so you're going to have in the end 6 pizzas. And that's going to be the answer. And again, there's actually another way to do these problems. I'm going to show you what that is here in a minute. But if you're just adding fractions together and they're both positive, a lot of times it's just easier. Add the whole numbers together, get this, add the fractions together to get your fraction, and then you have an answer there. So what if you had, along those lines, 7 2/5 plus 5 4/5? Okay, so you have the same thing. What is 7 plus 5? That's 12. So we'll just write the 12 there. All right, now we have to deal with these fractions, but the denominator is already the same, so I'm going to leave it the same. Now we add 4 plus 2 to get 6, so we have 12 6/5. So don't forget, what is this? This is 12 pizzas plus 6/5 of another one, but this is an improper fraction. So the way to handle that is just to write it out. 12 plus, what do we have here? How many times will 5 go into 6? It'll go 1 1/5, because the remainder is going to be 1, and I write it over 5. So 12 plus 1 is 13 1/5. 13 1/5, and that's the answer there. All right, let me do one more this way, and I'll show you another way to do these problems. 4 6/7 plus 6 5/7. So we have 2 positive fractions, 4 plus 6, these are the whole numbers, 10. And this fraction here is all over 7, so we'll keep that. 6 plus 5 gives us 11. So we've basically done the answer here, but this fraction here, 10, let's do plus just to make it clear. This fraction, how many times will 7 go into 11? It'll go 1 time. With 4 left over, we'll write it out of 7, 1 4/7. So ultimately, the 10 plus 1 will give us 11 4/7. 11 4/7. Now let me show you this next problem, because I'm going to show you a different way to do these things. Negative 6 1/5 plus 2 2/5. Now you could try to do this in the same way we've done before. There's nothing that's preventing you from doing this, but it's a pretty good opportunity to show you another way to solve these problems, and your teacher may actually prefer you to do this way, so I'm going to teach to you this way as well. Basically, if you want to, you can convert these to improper fractions and then add them, and then you kind of get rid of these whole numbers out in front, and it's a little bit easier to do that when you have negative fractions, or if you're subtracting them or something like that. So how would you convert this guy? 6 times 5 is 30. Don't forget your negative sign. So negative 30 plus 1 is 31 over 5. We learned how to convert to improper fractions earlier. Plus 2 times 5 is 10, plus 2 is 12/5. So you see, really quickly, we have changed it from an improper to this sort of problem. We've been doing those problems all night. So what we'll have next is we'll keep the denominator over 5 because the denominator is already the same, and in the numerator we'll have negative 31 plus 12. Negative 31 plus 12. Negative 31 plus 12 is going to give you negative 19 over 5. So that's basically the answer, but it's an improper fraction. How many times will 5 go into 19? Well, 5 times 3 is 15, so let's keep the negative sign there. 3. And the difference between 15 and 19 is 4, so I'll write it as 4/5. So negative 3 and 4/5. Negative 3 and 4/5, and that's the answer. So when you're given an addition problem with mixed numbers, a lot of times I like to add it this way. It works great. If you're doing subtraction, or if you have a negative number, or if your teacher just wants you to do it this way, you can convert them all to improper fractions and then do the addition subtraction. And then notice at the end we had to sort of convert it back. So you may have to do a couple more conversions, but you know, it's a little bit cleaner in a way because you can sort of see when they're in improper form, you can see it sort of a little bit more cleanly than having the whole number sitting out in front. So let's do it the same way. Let's say we have 5 2/9 plus negative 2 7/9, like that. Now we have a negative number here, so I just think it's going to be a little easier to convert to improper. 9 times 5 is 45, plus 2 is 47 over 9. Plus, this will be a negative fraction, 2 times 9 is 18. 18 plus 7 is 25 over 9. So 25 over 9, like that. All right, so we have the same common denominator, so we'll just keep it over 9. And then we have 47 plus a negative 25. All right, so we have 47 plus a negative 25. And so when we do that, we'll get 22 in the numerator over 9. And that's the answer, but how many times can 9 go into 22? Well, 9 times 2 is 18. And the difference between 18 and 22 will give us a remainder of 4, but I'm going to write that over 9. 2 and 4/9. So that's going to be the answer. And just to show you, these things that we're talking to you about, common denominators, finding common denominators, things like that, it applies to fractions with numbers, but it also applies just well to fractions with variables in them too, which we're getting into because this is a pre-algebra course. So if you were given something on a test, could be like a bonus question or something, 2a, where a is some variable, over c plus b over c. A lot of students would look at this and say, whoa, I have no idea how to do this, or we've been dealing with numbers, but just think for a second. This is a denominator. It's the same thing in both cases, so I can just keep it as c. Now in the numerator, I have 2a, and I'm going to add to it plus b. Now I haven't gotten too far into adding expressions together to you in algebra yet, but just know from now that you cannot add the top any further than you already have here because a and b are different things. This is like adding some number of buffaloes to some number of horses. I mean, you just can't really add them because they're not the same thing. So you just leave it like that, 2a plus b over c. Another example, if you had like 4 over 2a, let's say, and you added to that negative 6 over 2a. Well, these denominators are the same. So you keep it as the same, 2a. And in the numerator, 4 plus a negative 6 is going to give you a negative 2. So you have negative 2 over 2a. Now, we have talked about this sum. We have the same thing in the top and in the bottom, and everything's multiplied together in each case, so we strike them out. Okay, so what we're going to have here when we strike them out is we'll have negative, don't forget your negative here, 1 over a, because the 2 on the top cancels with the 2 on the bottom. The negative sign just stays out front. We'll have negative 1 over a. So I guess the moral of the story here is if you're given a fraction that has variables in it, don't get so worried about it. Just apply the same rules that you've already been learning and that you already know, and you'll be in really good shape. Now, what we've done up to this point is we've done fraction addition when the denominators are the same. That's sort of the easy case. Now we're going to go and look at what happens when they're different. And I'm going to give you a hint. You're just going to find the common denominator, and then you're going to keep on moving on just like we've been doing here. So it's really just one more step in there to perform. Okay, now the first problem is going to be 1/4 plus 1/2. 1/4 plus 1/2. So we look at this and we say the denominators are not the same. And that's absolutely true. So what we have to do is transform it. Now we notice we have 4 and 2, so we're going to choose to work on the second fraction. And we've done all this in the previous section. So what we'll do is multiply the top and the bottom of this by 2. Because we can multiply any fraction in the top and the bottom by anything we want as long as we keep it the same. So here we'll have 1/4 plus 1 times 2 is 2/4. 2 times 2 is the 4. Now we have a fraction that we know how to deal with. We have a common denominator there. So all you do is you keep that common denominator and you add the tops. 1 plus 2 is 3, and that's the answer, 3/4. And this makes perfect sense. If you have a half of a sandwich plus a quarter of a sandwich, you should have 3/4 of a sandwich. So that's basically it, ladies and gentlemen. You just insert that one step of finding that common denominator, and that is why it's so important. What if you have 4/10 plus 1/2? 4/10 plus 1/2. So I look at these and I say, well, I've got 10 and I've got 2, and those are different, but I know that 2 times 5 is 10, so I'm going to choose to work on that second fraction, 1/2, and I'm going to multiply it in the top and the bottom by 5. So what I'll have is 4/10 plus 1 times 5 is 5, 2 times 5 is 10. Now I have the common denominator is the same in both of these cases. So here I'll have 10, and I'll add the tops. 4 plus 5 is 9. This is fully simplified answer, so I'm done. 9/10. Now what if I have 1/3 plus 1/2? Now this one's a little bit more difficult because I can't really work on just one of these fractions. The only thing that pops into my head that I'm going to be able to work with is 6, because I know that 3 times 2 will give me 6, and I know 2 times 3 will also give me 6. So let me write this down so that I can begin to work on my fractions. And you can really choose any denominator you want. You don't have to choose 6. You could choose something else. You could choose even 12 in this case. Because 3 times 4 will give you 12, and 2 times 6 will give you 12. But choosing the smaller number is going to basically make your fraction a little bit more simplified. So I'll multiply by 2 in here and 3 over here. So 1 times 2 is 2, 6 because of that, plus 1 times 3 is 3, 6 because of this guy. And so at the end of the day, the denominator will be a 6. 2 plus 3 is 5. So I will have 5/6 for that answer. So you really see it's not that hard. It's just you really do need to understand the concept of finding that common denominator. But hopefully teaching it this way, you really have total latitude to choose whatever you want. And so there really is a lot of freedom in it, but a lot of times finding the common denominator really trips up a lot of students. So what if I had this? Same problem. I have to work on both of these fractions. 12 is a number that pops into my head because I know I can say 3 times 4 is 12, and 4 times 3 is also 12. So let me write my fractions in a way that I can kind of mess with them a little bit, like this. All right, I can take this fraction, multiply it by 4 in the top and the bottom, and I can take this one and multiply it by 3 in the top and the bottom. So what I'm going to have is 2 times 4 is going to give me 8, 3 times 4 is going to give me 12. 1 times 3 is 3, 4 times 3 is 12. So I'm going to have common denominator of 12, which is what I wanted. So my answer is going to have 12. 8 plus 3 is 11. So I'm going to have 11/12, and that's already fully simplified. If this were not fully simplified, I would simplify my final answer. So I see I have 8 and I have 2, and I know that 2 times 4 is 8, so I'll just work on the second fraction. 7/8 plus 1/2, and I will manipulate this guy by multiplying by 4, like this. So I'll have 7/8 plus 1 times 4 is 4, eighths because of the 2 times 4 there. And then I'll go ahead and keep the common denominator in my answer just like I always do. 7 plus 4 is 11. So 11 eighths is the answer, and I can leave it like that, but this is improper. So how many times will 8 go into 11? It'll go only 1 time with a remainder of 3. And I'll write it over 8. 1 3/8. And the rest of these problems, they're really not going to get any harder. We're just doing more practice. That's it. So don't expect some problems here that are just going to be really difficult and you won't be able to get them, because really fractions are not that difficult once you understand what you're doing. Just like anything else, you have to practice. What if I gave you 5/6 plus 7/9? So when you look at these two denominators, you see they're different, and you start thinking, what number can be the smallest number that I can pick so that I can basically multiply 6 times something to get me that number and 9 times something to give me that number? Well, I'm thinking 18, because I know 6 times 3 is 18, and I know 9 times 2 is also 18. So I'm going to rewrite my fraction, 5/6, and I'm going to rewrite 7/9 so that I can work on these fractions. If I'm targeting 18, 6 times 3 is 18, and 9 times 2 is 18. So I'll multiply this fraction by 2 and this fraction by 3. And so what I'll get, 5 times 3 is giving me 15 over 18, plus 7 times 2 is 14 over 18. So in my final result, the common denominator of 18 will remain. 15 plus 14 is 29, so that is right there. It's 29 over 18. That is the answer, but you know this is improper, so let's try to simplify it. How many times will 18 go into 29? It'll only go 1 time, with a remainder of 11. And I always write it over the 18 here. So 1 and 11/18. And that's the answer. So what we're going to do here in the next problem is I'm going to give you some mixed fractions that have different denominators. And you'll see that's not going to be a big deal. What about 2 1/3 plus 3 1/2? Now there's again 2 ways to really do this, and I'm actually going to solve it for you both ways just to give you a little practice. Since these are positive and they're just sort of mixed numbers, I can add them together. 2 plus 3 is going to give me 5. That's the whole number of pizzas I have. And then I'm also going to have the 1/3 plus the 1/2. 1/3 plus the 1/2, sort of sitting there. So really I just need to deal with this fraction here. And I've already actually added up 1/3 plus 1/2 in a previous problem, but let me just do it again. 1/3 plus 1/2. And the only thing I can think of is 6. That's going to be able to good common denominator. So I'll multiply by 2, and I'll multiply by 3. And so I'll have 5 plus 1 times 2 is 2/6, plus 1 times 3 is 3/6. Common denominator is 6. And so all I'll have is 5 plus, the new denominator is 6, so I keep it. 2 plus 3 is 5. 5 plus 5/6, we just usually write that as 5 5/6. 5 5/6 is the answer, and that's perfectly fine. But your teacher, you know, like I say, it may want you to do a little bit differently. Maybe it's a little bit easier for you to think of it this way. So what we can do is actually forget about all this as a separate way to do this, and let's convert this to an improper fraction. 2 times 3 is 6, plus 1 is 7/3, plus 3 times 2 is 6, plus 1 is 7/2. And so now we have 7/3 plus 7/2. I still have the same denominator of 3 and 2, so I'm going to write it as 3 plus 7/2. And I'm going to multiply this fraction by 2 and this fraction by 3. So when I do that, I'm going to have 7 times 2 is 14 over 6, plus 7 times 3 is 21 over 6. So I have the same common denominator. So I'll keep it, 6. And 14 plus 21 is 35. So I'll write that down. 14 plus 21 is 35. And then what I'm going to have next is try to simplify this. This is already improper. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. So it looks like it can go 5 times. 6 times 5 is 30. The difference between 30 and 35 is 5. I always write it over 6. 5 and 5/6. Look, you get the same answer in both cases. So whether or not you want to add the whole numbers and then add the fractions, or if you want to convert them to improper and then do the proper simplification, it's really the same thing you're doing in both cases. So you can see that dealing with mixed numbers is not that big of a deal. You just really need to make sure when you're doing all this stuff to work it one step at a time and just make sure that everything you're doing is totally legal thing to do. So what if we have 5 and 5/6 plus 4 and 2/3? Let's convert these to improper fractions in this particular case. 6 times 5 is 30, plus 5 is 35 over 6, plus 4 times 3 is 12, plus 2 is 14 over 3. So here we have 35 over 6 plus 14 over 3. And so we look at this, we have 6 and we have 3. So we kind of have it handed to us on a platter here. 35 over 6 we're going to leave alone. The 14 over the 3, we're going to multiply this fraction by, you guessed it, 2 over 2, because I'm trying to make 6. So I'll have 35 over 6 plus 14 times 2, 28 over 6. 28 over 6. And so at the end of the day, I'm going to get 35 plus 28 is 63 over 6. And here you have a giant improper fraction, so you just need to simplify that. 10 times 6 is 60, so it can go 10 times with a remainder of 3 over 6 over that. But 3/6 is actually the same as 1/2 because I can divide the top by 3, can divide the bottom by 3. So I'll have 10 and 1/2. And this is the answer. Now, you would get exactly the same answer if you add 5 plus 4 to give you 9, and then you add these two fractions and go through it. But this is the way that you'll very likely be asked to handle it on your exams. All right, now what if you have 4 and 1/4 plus negative 3 and 1/2? Okay, so you just handle it the same way. The easiest way to do it is probably to convert them to improper fractions. So 4 times 4 is 16, plus 1 is 17. 17 over 4 plus negative. 2 times 3 is 6, plus 1 is 7 over 2. 7 halves. And so I'm looking at this and I see 2 and 4. So I'm going to basically have to mess around with the second fraction, but luckily I have 2 and 4, so I know I can multiply this by 2 and by 2, and I'll get exactly what I'm looking for. So I'll have 17 over 4 plus 7 times 2 is 14 over 2. Like that, actually over 4, because 2 times 2 is 4. This guy goes into there. 2 times 2 is 4. So the denominator is 4, and that's going to stay in my final answer. What is 17 plus a negative 14? That's going to give me a positive 3. And that's already simplified. So 3/4 is your answer. And as I said before, a few minutes ago, when you're dealing with this stuff, a lot of times you worry about it if you see a variable in an expression. But let me show you a quick fraction when you're adding them together and you don't have the same denominator. What if you have m over 5 plus 2 times n over 8? So you might look at that and say, whoa, I have no idea. But just look at it. You have two numbers in the bottom. These are different. Let's go and find the denominator. What can I do with this? M over 5 plus 2n over 8. Now, you're looking for the smallest number that can be multiplied to give you basically the by one of these numbers to give you that denominator. So the least common multiple really between the two of these is going to be 40, because 8 times 5 is 40. So if you get nowhere else, if you can't find another number that works, just multiply them together and that'll get you what you need. So multiply by 8, multiply by 5. Because ultimately this is going to give you 40 in the denominator of both of these fractions. So here I'll have m times 8, just write it as 8m over 40, plus, just write this as 2 times 5 is 10, 10n over 40. And our denominators are now the same, so we're going to keep them the same in our answer. 8m plus 10n. And again, we haven't gotten a lot into adding, algebra expressions like this, but just as a preview for you, as we're going to get into this a little bit later, you can think of m and n, they're totally different things, so you can't really add this anymore. A lot of students will try to add 8 plus 10 and try to combine these variables. You can't do that because m is like pizzas, and N is like race cars. You can't add them together in the sense of algebra anyway. I mean, you can sort of lump them in a room and count them all, but really in algebra you can only add things when they look the same, when they're the same thing. You know, 8 m's plus 8 more m's will give you 16 m's. But in this case you have some m's here and you have some n's over there, so you can't really add them, so you just leave them like that. All right, but you see in the same case, you just deal with finding that common denominator, follow the rules that you've been taught, and you'll be in really great shape. So in this section we've covered a tremendous amount of material. Adding fractions is so important because it's in every class. You'll use it from every math class on out, from here through calculus and trig and everything else you learn beyond. You will be dealing with fractions. So do yourself a favor, get comfortable with them. Live and breathe fractions. I promise you, if you can do that, your odds of success beyond algebra is going to just go way up, because everybody that I help, if they're really uncomfortable with something, a lot of times it's because they're worried about fractions. But if you understand all of this and go into the next section and keep going and do really well with that, you're going to have such a great understanding of fractions that they'll be your best friend. You won't be frightened of them, so you'll do really well in all of your exams and the future material beyond this.